Good afternoon, everybody. Myself Akshay Jilowa, Senior Lecturer, Government Polytechnic College for Girls, Jalandhar, and today I am here to discuss with you the topic television camera tubes. So, this will be covering under subject consumer electronics. So, camera tubes basically what are the camera tubes, first we will discuss, we will get ourselves introduced to the camera tubes and then we will discuss the details of these tubes. Outline of lecture, these are some of the topics which will be touching one by one in this lecture during the course of lecture. First camera tubes, what the various camera tubes are, then basic principle of those camera tubes, how they operate, what is their working principle, and then types of camera tubes. So, there are various types of camera tubes, we will be discussing some of them under this heading. Television camera tubes. An electron tube use a light sensitive material or receptor that converts an optical image into an electrical television video signal. So, this basically is the primary function of the camera tube. The tube is used in a television camera to generate a train of electrical pulses representing the light intensities present in an optical image focused on the tube. So, it is the corresponding electrical signal, as I said, these are the electrical pulses. Electrical pulses, these electrical pulses are corresponding electrical pulses to the simultaneous optical information present on a particular location of any object or any scene. So, corresponding to that electrical pulses are produced. Each point of this is interrogated in its proper turn by the beam in tube, and an electrical signal corresponding to the amount of light at that point of optical image is generated by the tube. This signal represents the video or picture portion of television signal. So, for any particular spot or any particular region or any particular area of the picture, a particular beam spot scans that image, and that particular area corresponding to the light intensity at that particular area, a corresponding electrical signal or electrical pulse is generated. Basic principle. So, basic principle of operation of these tubes is photoconductive effect one, second is photoemission effect. So, now we will discuss what the photoconductive effect is and what the photoemission effect is. First, photoemission principle. Certain metals emit electrons when light falls on their surface. These emitted electrons are called photoelectrons and the emitting surface a photocathode. Light consists of small bundles of energy called photons. When light incident on a photocathode, the photons give away their energy to outer valence electrons to allow them to overcome the potential energy barrier at the surface. So, as all we know what the light is nothing but it is a combination of small bundles of energy. These are also called energy packets or these are also called photons. So, these energy packets or energy bundles or photons, when they strike on the surface of photocathode, which is a surface which can emit the electrons when light falls on it. Then what happens, the energy associated with the photon, as we say this, these are the energy bundles or photons or energy particles or packets of energy. So, that energy contained in the packet or in the bundle or in the particle, that is transferred to the electron. So, in the process what happens, this the energy of electron increases, and it increases to such a level that it crosses the barrier which is called potential energy barrier of the surface. This barrier is nothing but this is the energy required by an electron to get out of its orbit. As we know, electrons revolve around the nucleus in their orbits. So, from a particular orbit, if an electron is to be removed, it moves in a particular orbital. So, if sufficient energy is supplied, which is enough to cause emission of electron, that happens because the energy is so high that electron does not remain in that particular orbit, and it moves to the higher orbits which are not present consequently in that particular matter or material. So, it comes out of that surface. So, in this way electrons are emitted from the surface of photocathodes. Energy associated with the photon is transferred to the electron, and energy of the electrons becomes so high that it crosses the potential barrier, and when it crosses the potential barrier, then what happens, from its original state of revolution around the nucleus, it comes out of that. That energy exceeds the centripetal force due to which it is revolving around the nucleus, and it comes out of the surface or orbit. The number of electrons which can overcome the potential barrier and get emitted depend on light. Alkali metals are used as photocathode because they have very low work function. Now, the number of electrons which can overcome the potential barrier and get emitted depend on the light, means what is the intensity of light, how much light is falling on a particular area, depending upon that number of electrons will be emitted off the surface. If more light is falling, it means more energy is being transferred from the light or from the photons or from the energy packets or bundles to the electrons, and when one electron leaves the orbits, then it happens to some other electron present in the matter, and then to the next, and so on. So, in this way, more the light falling, more will be the number of electron which will be liberated from the surface of photocathode. So, it is directly proportional to light. So, it depends on the light. Potential barrier means how many energy bundles are present which will cause the liberation of electron from the surface of the material. So, that depends upon the light, more the energy, more the electrons which are emitted. Next, alkali metals are used as photocathode because they have very low work function. So, what this work function is? Work function is nothing, as I explained earlier. This is the energy required to liberate an electron from outermost shell. So, in the because this is the minimum energy. First of all, the electron revolving around the outermost shell will be liberated, it will leave the surface. So, this is the minimum energy which is required by an electron to get liberated from the surface, or to overcome the centripetal force, or to overcome the force which keeps it intact in that particular orbit or in its state. So, it is that energy, and in alkali metals this energy is very low. When energy is very low, it means it is very easy to remove an electron from the outermost shell of the alkali metal. As we all know there is only one electron and it is loosely bound. So, these loosely bound electrons are very easy to get liberated from that surface. So, these are preferred. These are preferred, so that with very less energy, with very less input, we can have more number of electrons for the purpose. If it is conduction or some other purpose, we can use those electrons. Cesium silver or bismuth silver, cesium oxides are preferred as cathode surface because they are sensitive to incandescent light and have spectral response very close to the human eye. So, spectral response of these particular metals, it is very close to the human eye. So, that is why they are preferred and they are more sensitive also. Next, photoconductive principle. We discussed photo emission, now photoconductive. In some metal, when light photon fall on it, then its conductivity or resistivity change. Semiconductor metals like selenium, tellurium and lead with their oxide have this property known as photoconductivity. The variation of resistance at each point across the surface of material is utilized to develop a varying signal by scanning it uniformly with an electron beam. So, this is photoconductivity. Photoconductivity means, as it has been in some metal, when light photon fall on it, its conductivity or resistivity changes, means as we discussed in photo emission, when light falls on the matter or the surface, the electrons are liberated. Here what happens, when light fall on the material, then its conductivity or resistivity changes. Conductivity or resistivity changes means its conductivity increases, then resistivity will decrease. As we know, conductivity and resistivity, they are inversely proportional to each other, reciprocal of each other. So, when conductivity increases, then resistivity will decrease. So, such metals selenium, tellurium and lead with their oxide have property known as photoconductivity. So, this is the property by virtue of which the conductivity or resistivity of a material changes when it is exposed to the source of light. As source of light is constituted with photons. So, it is called photoconductivity. This property is used for variation resistance at each point across the surface of material utilized to develop a varying signal by scanning it uniformly with an electron beam. In our camera tubes, what we do, we use this principle for the purpose of scanning. We continuously scan the photoconductive layer, and on a particular area where the beam spot is focused, the variation in resistance at that point is noticed, and it is a continuous process. We keep on doing it for all the pixels, it is called for picture element, this name is given. For all the spots, we keep on doing it and we keep on getting the corresponding electrical signal, because the resistance of every point is different or conductivity is different, because the amount of light falling on that particular area is different with respect to its neighboring spots. So, as it varies, so we can say that the signal will also vary, because it is directly proportional to the light. More the light, more will be the variation, lesser the light, less will be the variation. What is the intensity, how much is the variation, it can be seen with the help of that beam spot, which is used for the purpose of scanning. Now, next types of camera tube. There are various types of camera tubes. So, these three tubes are very popular: Image Orthicon tube, Vidicon and plumbicon. These are the 3 tubes which are basically used in cameras. So, these are called camera tubes. So, Image Orthicon is the earliest one and the most popular of them is Vidicon. Image Orthicon, this picture shows the Image Orthicon tube. Here is the lens, here is the object, and this is photocathode. Photocathode means the cathode from where the electrons will be liberated. These are focusing coils. This coil is focusing coil, this is also focusing coil, this is target screen, this is scanning beam we just discussed. For various spots we will be using this beam for continuously checking that how much conductivity has varied with respect to its neighboring areas. This is anode. Electron multiplier section is used in this particular tube. These are the alignment coils, and this is electron gun which generates electron beam for the purpose of scanning. These electrons are the emitted electrons. So, from here the light from the light falls on the object, and from the object when it is reflected, it falls on the photocathode through camera lens, and when it falls on the photocathode, depending upon the light intensity, various number of electrons will be liberated from the different areas of the photocathode, and those electrons will travel from here to the target screen. So, when they strike with the target screen, the how much variation they have caused, it is noticed by the electron beam which scans the various areas, and this scanning is nothing but this is a function of time and space, at which time which space has been scanned. So, initially suppose they scan, if this is the screen, we say this is the screen, we are seeing this from the side angle. If we see it from the front, this will be the screen, and this spot, if I say this spot, this will be the first spot or pixel number 1. So, variation in this is recorded, then beam moves from this area to next area, means it moves from top left hand corner to the top right hand corner, and then it flies back, this is called retrace, and again from in the next line from left to right, and in this process, in this way it scans whole of the screens, and when whole of the screen is scanned, we know how much variation the particular picture or a particular scene has caused to the various spots, and the number of electrons being liberated from that area, they are the direct indication of that variation. Image Orthicon works on the principle of photo emission. This is photoemissive. It has 3 sections: image section, scanning section, and electron gun cum multiplier. This is the only, this is a special tube which has electron multiplier. Image section, it contains a glass plate, as I explained, coated with silver antimony, serve as photocathode. Photocathode is something or a material or a cathode which gives us the electrons when it is exposed to the light or when photons strike with it. Then lens assembly, light from the scene to be televised is focused on the photocathode surface by lens system. So, a particular focus length is there. So, due to that focal length, this a particular image is focused on the photocathode. Photocathode surface is semi transparent, and light rays penetrate it to reach its inner surface where electron emission takes place. So, this photocathode surface, as it has been written, it is semi transparent. Light falls from one end and that end is transparent, on the other end is photoemissive material coated, and when light penetrates through that area, the area which is facing the glass face plate or lens, then it penetrates that area and strike with the photocathode surface. So, when it strike with the photocathode, depending upon the number of energy particles or number of photons striking at a particular area at a particular time, the number of electrons will be liberated. So, for different areas, as the light intensity is different, number of electrons liberated will also be different. So, those different number of electrons which are liberated, they travel from that point, means photocathode, to the target plate. So, for various areas, as light intensity is different, number of electrons emitted will also be different. Next is target plate. When electron emit from cathode, it cannot store charge, being a conductor. When electron are emitted from the cathode, it cannot store the charge because it is a conductor. For this reason, the electron image is made to move towards the target plate located at short distance from it. So, because when otherwise if electrons are liberated from the cathode, it should store that charge, but it does not happen because it is a conductor. So, it moves toward, those electrons are moved towards the target plate, which is located at a at some distance from the photocathode. The target plate is made of a very thin sheet of glass and can store charge received by it. This is maintained at about 400 volt more positive with respect to photocathode. So, this target plate is what? It is made up of a very thin sheet of glass and it is capable of storing charge. So, when electrons are liberated from the photocathode, they move toward the target plate because it is kept at 400 volt more positive with respect to photocathode, means the potential difference or the difference between the photocathode and the target plate is 400 volt and it is positive. When it is positive, as we all know, electrons are nothing but they are negatively charged particles. So, when such a high potential difference is there and it is a positively charged layer with such a high potential difference of 400 volts, the electrons immediately travel from the photocathode to the target plate. When electron move from photocathode to target plate, there is chance that it may repel each other. This can result in distortion of the information available as charge image. So, there is every possibility that when electron will move from photocathode to the target plate, they can repel each other, because if two electrons are moving and they are moving simultaneously and from the neighboring areas, as both of them are negatively charged particles. So, a force of repulsion will be there and due to that force of repulsion they may be repelled, and when they are repelled, it means their trajectories will be altered. So, to prevent this, divergence effect and axial magnetic field generated by focus is employed. So, this is additional field which is magnetic field which is generated to focus the electrons, so that they follow their trajectory and they do not get repelled by each other or by the presence of each other. So, they travel in their own trajectory. This magnetic field impart helical motion to electrons and focus them on target plate. So, with the help of this, the electrons are focused on the target plate, they will strike with the very point which they are intended to strike or which we expect them to strike. The image side of target plate has coating of cesium that emits secondary electron. These secondary electron is collected by wire mesh which is located at front of target plate. So, this is a very important assembly. The image side of target plate has coating of cesium. So, this secondary electrons. So, as electrons will strike with the target plate, they are also containing some energy. So, that kinetic energy will cause some secondary emission of electron from the target plate. So, that secondary emission of electron is controlled with the help of a mesh structure, and this mesh structure ensures that secondary electrons is collected by that wire mesh, and it is located just in front of the target plate. The positive charge appeared on target plate is proportional to the light intensity distribution on the photocathode. This is very obvious, the positive charge, it is proportional to the distribution of photocathode. Now, the next section, scanning section, it contains fine electron beam, focus alignment coil, deflection coil, horizontal deflection, vertical deflection. So, these are the constituents. Electron gun assembly and multiplier, it contains electron gun and multi-stage electron multiplier. Next tube is Vidicon. Principle is photoconductive. So, principle of image orthicon was photoemission. Principle of Vidicon is photoconductivity. It has 3 sections. One is target section, second is scanning section, and third is electron gun. This figure shows Vidicon. Plumbicon is also same. In Vidicon and Plumbicon, the only difference is between target construction, otherwise both the tubes operate on same principle, their construction is also same. Here we have a glass face plate, this is target connection, this is target, here is focusing coils, these are horizontal and vertical deflection coils, and these are alignment coils. First I will explain how this Vidicon works, primarily what happens in this Vidicon. Here the image or the scene is kept before this tube, this is the glass face plate. So, here we have the image. So, light which falls on the image gets reflected from the scene, and after getting reflected from that particular scene, it falls on this glass face plate, and here is the target behind that glass face plate. So, as we just read that principle of operation of this tube is photoconductivity. So, it operates on the principle of photoconductivity. So, here a photoconductive layer is deposited. So, when light falls through this on this photoconductive layer, as the property of photoconductive layer is that when light will fall on it, it will change its conductivity or resistivity. So, when conductivity changes, it means different areas have different conductivity, which depends upon the light being emitted from the scene at a particular location. So, when light emitted is different for different areas, different areas will be having different conductivity, because number of electrons striking, number of photons striking at that area are different as compared to the other areas. So, its photoconductivity will also be different. So, that conductivity can be measured with the help of scanning. So, what the scanning does? We use an electron beam for the purpose of scanning. This electron beam is generated by the electrons, and for its journey from the electron gun to the photoconductive layer, it is controlled by different controls. This is grid number 1 and 2 as it has been seen. These are focusing grid and controlling grid. So, electrons are focused, controlled, and then are accelerated so that they travel from electron gun to the photoconductive layer. So, under the effect of horizontal and vertical deflection coil, this electron beam travels and it strikes on a particular location.